Hello everyone, this is Engineer Selassie from Halo Academy Brain Boosters. Today let's discuss about data mining and machine learning. And this topic is very hot, so today I want to discuss some of the points. And data mining and machine learning are two different things. Okay, so it's good to know the difference between data mining and machine learning. We will try to see in this specific video what I want to discuss is about the neural network simulator. Okay, I'm going to use the BasicProp program, and we're gonna do one neural network simulation. Okay, and what we are going to do is we're gonna generate, for example, program. Okay, a program, we're gonna encode a program like a 7-segment display. Okay, this is a 7-segment display that a program to recognize. Okay, to encode an input, a binary like a 7-segment display. Okay, this is one of the old topic in machine learning, how to recognize a 7-segment display. Okay, so we're gonna use artificial neural network concept in machine learning, and we're gonna go through step by step how to develop this program. Okay, because as you know, we have to train our system in artificial neural network. Before that, there is two concepts I want to discuss. Before that, there is two concepts in machine learning. We have a perceptron. Okay, this is one of concept, perceptron, and the feed-forward neural network with a backpropagation algorithm have similar architecture, but they have different training methods. Okay, so perceptron is another concept, and the feed-forward neural network with a backpropagation algorithm is another network. This is another architecture. So what is it? For example, training process. In the concept of training process, perceptron is trained by changing the weight in accordance with a straightforward learning algorithm. After each sample that is incorrectly identified, the weights are progressively adjusted. Okay, the perceptron update rule, which modifies the weight in proportion to the inputs and an error signal, serves as the foundation for more learning rules. Perceptron is just like a kind of a single layer. Okay, a single layer like the input, and we have the weight. Then we're gonna have the summation. Then we're gonna have an add function. Then we're gonna have the output. This is a simple procedure. And the other one is feed-forward neural network with backpropagation. This is another type. And forward propagation and backpropagation are the two primary stages of training a feed-forward neural network with backpropagation. Forward propagation involves feeding input data into the network, which then calculates outputs. The error between the intended output and the anticipated output is then sent backward through the network using backpropagation, and the weights are modified using the gradient descent to reduce the error. These are the two artificial neural network models I want to discuss in this video. And the architecture, as we have seen, the perceptron is a single layer neural network that has one or more inputs, weight assigned to each one, a summation function to determine the weight sum of the inputs, and an activation function to generate the output. Since like sigmoid function, since a step function is used as an activation function, and it can only solve the problem that linearly separates. In the other one, feed-forward neural network with backpropagation. This is a feed-forward neural network. Is made up of several linked layers of neurons. There are 3 levels to it. Unfortunately, we can have as long as layer we want, but the name of the layers, we have an input layer, and we have also the layer in the middle, which is the concealed layer. This is a secret, which are function, and we have the output layer. Okay, so we have, these are the 3 layers. So the network neurons are all linked to those in the layers above them. Then we're gonna have the activation functions used to the neurons in the hidden layer. Okay, enable the network to learn non-linear correlation between input and outputs. So in general, these are the schematic diagram of the perceptron and the feed-forward neural network with backpropagation. These are the input, weight, summation, activation, and output. This is in the perceptron case. But feed-forward neural network with backpropagation, we're gonna have input, and we're gonna have hidden layer, and we're gonna have output layer, and in the middle we're gonna have the weights as well. So each link in the feed-forward neural network has a weight that is adjusted using the gradient descent technique during the backpropagation phase, and the network can learn, okay, intricate pattern and connections in the data to the hidden layer, okay, through the hidden layer. Overall, the feed-forward neural network with a backpropagation is more complicated and may learn a non-linear correlation between input and output, while the perceptron is a simple model with a single layer. This is the very important point. For example, for the 2 types of machine learning models like the perceptron and feed-forward neural network with a backpropagation algorithm, there are a lot of videos, and in this particular video we are going to do a machine learning, one of the machine learning implementation. We're gonna do a 7-segment display, okay, how to recognize a 7-segment display, and our program should identify numbers as well as alphabets, okay, and we're gonna generate trainings, okay, we're gonna generate trainings as well, because we have to train our program, okay, to identify what is the difference between machine learning and programming. The programming is just you write a script, okay, you write a script, and the program will do as per the script which is generated by a programmer. But in machine learning, the beauty of machine learning, the output will learn from from the past, from the learning the data we gave, and it will give a best decision. Okay, that is the beauty of the machine learning. It will not stuck on the program. Okay, it will learn from the outputs and it will update and it will give us a better output. So that is the idea. So facial recognition is another machine learning application, and we have a lot of applications, but today what I'm going to concentrate is on the 7-segment display and alphabet, how to recognize alphabet, and the output formats are encoded in binary format using ASCII values. So what I'm going to do, first we have to generate our training file. We have to train our machine. In machine learning, the first thing is we have to generate our machine. Okay, we have to generate our training data. So what I'm going to do, let's say we have number 8. Okay, we have number 8. So what we are going to do in the number 8, so let's say we're gonna give numbers, okay, for the segments. For the 8 segments, we are going to give number 1, 2, 3, 4, 5, 6, 7. Yeah. So this is the number of inputs. Okay. So if we were expecting 1 to appear, so only the 2 segments will be on, and the other segments will be off. Okay, the other segments will be off. What I'm saying is, let me, if I have the number, I'll show you in a minute. What I'm going to do, the number, this is okay. So for example, the programming assignments we are going to do is we are required to build and train a neural network to recognize letters of alphabet and numbers based upon their design using a 7-segment display where each segment of the display is one input into the neural network. So what we are going to do, the neural network which we are going to develop should recognize numbers and alphabets. Okay, how we are going to do that? For example, using the numbering of the segment in the picture. As you can see, we have 8 here. So let's say we say 1, 2, 3, 4, 5, 6, 7. Now our training data should be, for example, if we were supposed to show number 1, then only 2 and 3 will be on, and 1, 5, 7, 6, 7 will be, 4 will be 0. Okay, and if we were supposed to show 2, so 1, 2, 7, 6, 4 will be on, and 5 and 3 will be 0. Something like that. Okay. And for the alphabet, for example, if you were supposed to show A, so 1, 5, 7, 2, 3, 6 will be on, and 4 will be 0. And if we were supposed to show B, so B will be 5, 6, 7, 3, 7 will be on, 1 and 2 would be 0. So our training data should show this. So what we are going to do, let me show you. I generate a training data. Let me open it in Word. Okay, let me open it in Word. Text editor. Okay, I'm going to open it in Notepad. So I will show you what I did. So my training data, the number of pattern I generate 17. Okay, because 17 number of patterns are generated for the number 0 to 9, that is we have 10 training datas, and for the other 7 is the alphabet, okay, for the alphabet. So what I did was, this is a training data number, okay. So what I did was, for example, 0, if our data should show 0, that means only number 7, for example, 1, 2, okay, 1, 2, 3, 4, 5, 6, this all should be on, yes, okay, only the 7 should be 0, okay, and if it is 1, okay, this is the 7th digit, the 7th digit will be 0, and the other all should be 1, they should be on, okay, so it is in the reverse direction. So the 7th digit is 0 and all others are 1, and we map this pattern with the ASCII binary numbers, okay. The ASCII 0 in binary is, you can check it, 0, 1, 1, 0, 0, 0, 0. So this is the binary. So for our pattern in machine learning, in our neural networks, 0, 1, 1, 1, when it shows this, then we learn our system, we told our system to show us the binary 0. And to show 2, only 2 and 3 will be 1 and the other 0. So as you can see, 1 is 0, 2 and 3 is 1, 4, 5, 6, 7, all 0. This is for us to recognize our system 1, and in binary 1 is 1, 0, 0, 0, 1, 1, 0. So this is binary representation and this is 1. So it will go like that. For example, 3, if we were supposed to show 3, so what we can do, 5 and 6 will be 0. As you can see, 5 and 6 is 0. And in binary, 3 is 1, 1, 0, 0, 1, 1, 0. So we will continue like this, okay? And the alphabet also the same. The last 7, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, it starts from A. Okay, if we were supposed to show A, only 4 is 0. So as you can see, 4 is 0 and the other are 1, and this is a binary representation of A. And the binary representation of B, the binary representation of C, the binary representation of C and D. And in our machine learning, this is the pattern file. This is .pat file. We're gonna load it, okay? Number of input is 7 and number of output is 7, and the pattern we generate is 17 pattern. We have to learn our system, neural network in machine learning. This is one of the beauty. We're gonna have million type of learning our machine, but this is the one I generated here, okay? So this is the machine learning pattern file. We're gonna load it in our neural network, okay? This is, we're gonna use BasicProp version 1.4, and we're gonna generate our input, our hidden layer and our output layer. So what I'm going to do, let me configure the pattern, okay? So as you can see, inputs, let's say we're gonna have 7 inputs, okay? And the layer in the middle, we can make it 6, okay? Okay. And This is the output layer. Okay, the input layer also, let's say we have 7 layers. And total number of layer, we can make it 3. Okay, we can make it 3 or we can make it 4 as well. No issue. Okay, we can make it 4. And if we make 4, as you can see, the layer, we're gonna have 2 options. Okay, layer 1 and layer 2. This is the hidden layers. We're going to have 2 layers. So if, just give me a minute, what we can do, I can use one sample. Okay, I can use one sample. For example, we're going to have 2 layers, and in the middle, as you can see, we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in our here, we can make it full 10. Okay, we can make it 10. And for the bias part, both have bias. Okay, and the input, okay, for the input also we have bias. So all this is okay. Then let's say apply. Okay, let's say apply. Let me close this one. So when we say apply, okay, and close it, okay. So this is the very complicated machine learning pattern. As you can see, we have input layer and we have the middle layers, and the function we are going to use is sigmoid function. Okay, sigmoid function. And we have also the output also 7. So before we do anything, we have to load our pattern. Okay, pattern file we have generated now. So this is the pattern. So what I'm going to do, I'm going to open it. As you can see now, all the 17 patterns are generated. And as you can see here, we have the learning rate, we have 30%, and the momentum, we have 80%, and the learning state, we are going to start from 100. And what is learning rate? Learning rate is the machine, the rate the machine is learning, our system is learning. Now we are going to generate our first neural network system, which will recognize number and alphabet. So the learning rate we say is 30%, and the momentum is like, we can make it 90%. Okay, 90% means from the first trial, our machine should learn something. Okay, and it will take 90% of the previous learning, okay, the data learning, and it will use it for the second stage. So this is the momentum, how our neural network should learn. And the learning state is 10, and the weight range is -1 and 1. And as you can see, the pattern is already learned. And before we do anything, what we have to do is we have to train our system to learn, because when it sees the pattern, this is our pattern. So as you can see, when it sees 0, 1, 1, 1, 1, 1, 1, and it should know in binary 0, 1, 1, 0, 0, 0, 0. So this is 117 learning pattern we have generated. So what we are going to do, we have to train our system. As you can see, we train it now. Okay, we train it. Now we have to see the error now. For example, if I, as you can see, this is the error, okay? The error progress, as you can see, is here. So if I say test all, as you can see, the average pattern error is 1.2926, which is a huge error. It's not allowed. We have more than 5% of the error, okay? So we have to train our system, our neural network, okay? We have to train our neural network until the error pattern is. So learning step is 100. Now let's make 200. Let's train it, as you can see now, and test all. As you can see, the error is now 1.27. It's a huge significance, yeah? The first one is 1.29, but now 1.27. Okay, let's continue. Let's make 500. And let's test all. Oh, as you can see now, the trend, the pattern, the average per the error is 0.93. It's a huge decrease, yeah? So our machine learning is getting good. So let's train it. Now test all. Oh, you see 0.6599. Again, let's go to 2000 and test all. Oh, you see 0.185, 0.815. Again, let's go to 5000 steps. Train, test all. You see 0.05. Oh my god, almost in 5000 we have got already the desired amount of error margin. And let's make it 10,000. Train it and test all. 0.028. Our neural network is becoming really nice now. And let's make it 20,000 and test all. As you can see, 0.01, almost the error, because we train our neural network in our simple neural network simulation. This is the beauty of machine learning, okay? This is the beauty of machine learning. And let's say 50,000, for example. We are training it. And we are training, you see, okay, 0.011 almost. And if you continue training, for example, 100,000 steps, test all, almost 0.0075. So our neural network, okay, our neural network is best because now we're gonna check each. For example, the first one, as we have seen, to see 0, the input is 0, 1, 1, 1, 1, 1, 1, and with the output we expect is 0, 1, 1, 0, 0, 0, 0. This is the training data. So let's test 1 now. Okay, as you can see, our input is 0, 1, 1, 1, 1, 1, 1, and with this sigmoid function, the input, as you can see, 0.005, almost 0, and 0.995, 0.995, 0.007, 0.006, 0.006, 0.002. So this is our machine recognition. This program is working well. Okay, let's continue the second one, for example, test 1. The input is 0.000.110, 0.000.110, and the output is 0.110.001. As you can see, 0.000.1, 0.003, 0.003, 0.003, 0.996. So it works well. It works well. And we continue like this. Test 1. As you can see, 110.110.001. This is the input, and 0.110.011 is out. This is completely very nice machine learning algorithm. So this is neural network, the neural network which recognize numbers and alphabets. So this is very impressive. This is very impressive, as you can see. Very impressive results we are getting. So our machine the neural network which we did is very nice. It works very nice. As you can see, the result is very good. The result is very good. So this, as you can see, the error, the graph also shows almost nil, zero, nil. So in this way, what we did is we generate, okay, we build and train a neural network to recognize letters of alphabet and numbers based upon their design using 7-segment display, and where each segment of the display is one input into the neural network. Okay, so this can be used for lighting purpose and displaying A, B, C, D, E, F, H, and the number from 0 to 9. So for you can write 0 until 100 or 1 million, and you can include all the alphabets from A to Z, and your neural network will recognize. Okay, if you train it, if your pattern is, if you learn your system neural network accordingly, then at the end of the day, your machine, the neural network, will work very well. So this is the beauty of feed-forward neural network with backpropagation. Okay, this is one of the hot area in 21st century now in our world, machine learning and robotics and everything. So in this short video, I have shown you, okay, we have seen the beauty of machine learning, perceptron. I will come with another video. It's very simple, but for this video, we have seen the feed-forward neural network with backpropagation with segmental function, okay, segmental function. And we have seen that our training data and our program, now our machine, now recognize the letter and alphabets very well, and the error margin is almost zero. And this is a neural network, and I have used the BasicProp version 1.4 program. And thank you so much. I will come up with another helpful video next time. I hope this video was helpful for you, and I invite you to go deep inside and read more about machine learning and neural network. And this is one of the simplest example, and I hope you will use it. Thank you so much. Bye bye.